Hey! Today we're going to continue to look at fractions and their equivalents. In the last video we had a look at what equivalent fractions are, and this video we'll look at how we can find equivalent fractions to compare and order. So if we have a look at two fractions here, we have got 2/5 here represented here, so 2 out of 5 of the boxes that make up this shape are green, so 2/5 of them are green. And in this shape here we have 9/15 of the boxes that make up this shape are green, because we've got 9 out of 15. Now sometimes when we're looking at fractions and proportions, we want to order them or compare them to find out which one is bigger. Now that's quite difficult when the fractions have different denominators. So in this case 2/5 with a denominator of 5, and 9/15 we have a denominator of 15. So the shapes have been split up into different amounts. This can make it a little bit tricky when we are finding out which ones are bigger, or we want to compare the sizes of them. So to do this we would need to change one of the fractions so that it has the same denominator as the other fraction, and this will help us to compare much more easily. Now when we do this, we're not actually changing the size of the fraction, we're just changing it into a different equivalent fraction, so it represents the same proportion. So I'm going to show you a couple of ways to do that in this video. So in these ones, it does rely slightly on your use of times tables and knowing your multiples. So if we have a look at this fraction here, 2/5, I'm going to try and change this one so it will have the same denominator as this fraction here, which is 15ths. Now if I was doing this visually, I could just up the amount of boxes I've got until I've got 15. So that's 5, 10 and 15. The proportions have stayed the same because I've kept the same amount of green boxes in each group. And now I've got 15, the new fraction I could write would be, let's count up, shall we? So we've changed this fraction now so that it is out of 15. So we've got 15 boxes, so it will have a denominator of 15. Then we can count up how many of them are green. 1, 2, 3, 4, 5, 6. So actually 2/5 as an equivalent fraction with a denominator of 15 would be 6/15. And then if we were comparing, we could see which one was bigger out of 2/5 and 9/15. We can see we've got 6/15 and 9/15. We can see that 9/15 is clearly bigger. So that's one way of doing it. We can also do it the other way. So instead of changing the 2/5, we could find an equivalent fraction of 9/15 that would be the same. So in this case we're simplifying the fraction. So I'm aiming to change this into groups of 5, because I'm aiming to get the same denominator as the other fraction in groups of 5. So if I split up this shape, so we are in groups of 5, now it will remain the same proportion because I'm not changing the amount of green. I'm not changing the amount of green boxes. They're all staying the same in each group. So I've split this into 3 groups of 5, but each group has got the same amount of green. Then if I calculate the fraction of each new group of 5, so we've got 1, 2, 3, 4, 5 in each group, so that would be 5. And 1, 2, 3 of them are green, so the equivalent fraction of 9/15 would be 3/5. And then we could compare again which one would be bigger, 2/5 or 3/5. Obviously 3/5 would be bigger because more of the shape is green. So that's how we can look at this visually. If we were doing this just with numbers, there's a couple of ways we can do it. There's numerous methods for this, so I'm just going to show you one that I use. The way I think about it is, if I want to make sure I can order these two fractions, the first thing I need to do is make sure that both of the fractions have the same denominator. So I'm going to change one to the other. Now this is where your times tables and your multiple knowledge comes in, because what you've got to look for is common multiples. So I see 5, and I know 5 goes into 15. I know that 15 is a multiple of 5, and 5 is a factor of 15. So I know that I can find an equivalent fraction quite easily by changing this fraction so it has a denominator of 5. So the way I would go about doing this in a layout, I'd rewrite my fraction like this. I'm finding an equivalent fraction, so it's going to be equal. I'm aiming to have a new denominator of 15, so it is the same as this one. Then I'm going to ask the question, what has happened to the 5 to get to 15? What have I done to that 5 to get to 15? So instead of thinking about it in terms of addition, because if you remembered in the last example, what we actually did is we added 5 repeatedly, which is multiplication. So think about it in terms of multiplication. To get to from 5 to 15, I've multiplied that by 3. Now, a little key rule is whatever you do to the denominator in a fraction, if you want the fraction to stay equivalent, as in equal proportion, you need to do the same to the numerator. So I'm then going to multiply the numerator by the same amount, which is 3. So 2 times 3 gives me 6. And that would give me an equivalent fraction. So 2/5 is the same as 6/15. And then I could compare the two fractions, 6/15, which is the same as 2/5, and 9/15 to see which one is bigger. Okay, so this is just more of a way of laying out your methods rather than telling you the understanding behind it. So if I just move these over here just for a second. Now, we can also do that with the second representation we looked at here, where we were changing the 9/15. We were simplifying that so it had a denominator of 5. And I would go through the same process. So but we're working kind of the other way this time. So this time I'm starting with 9/15, and I want to simplify it so that the new denominator would be fifths. So again, ask the question, how have I gone from 15ths to fifths? Now we're working the other way here, and it's getting smaller, so we know it's going to be division. How much have I divided 15 by to get to 5? And in this case it's 3. And once again, whatever you do to the denominator, you should do to the numerator if you want an equivalent fraction. So I'm going to divide my 9 by 3 as well. So 9 divided by 3 is 3. So when the equivalent fraction would be 3/5. So 9/15 is the same as 3/5. And then once again, we could rewrite to compare. So we had 2/5, and the equivalent of 9/15 would be 3/5. And then we can quite clearly see which one is bigger by comparing the numerators. So when the denominators are the same, it allows us to compare more easily, to find out which ones are bigger, to order, and then also to add and subtract. Now, when we have fractions that have got different denominators, and it's not clear straight away what those what the same denominator would be, we have to use a slightly different method, and I'll go into that in the next video. Okay, so until next time, keep having fun with your equivalents, and I'll see you in the next video.